create a 3-axis finishing toolpath based on slope angle. After completing this video, you'll be able to create a 3D contour toolpath and use slope to restrict a toolpath. In Fusion 360, now that we've created our 3D adaptive toolpath, let's carry on with our 3-axis sample part and let's focus on using some of the finishing strategies. At this point, we're going to navigate to our 3D dropdown and we're going to start with a 3D contour. A 3D contour strategy is one that's great for finishing or semi-finishing near steep or vertical walls. So we're going to use this toolpath and identify some of its options to see how we can restrict it to certain areas. First, we're going to change from a 1/4-inch flat tool, and we want to make sure that we're using a ball end mill. So navigate to your 3-axis library, and let's go ahead and make sure that we're using the 1/4-inch ball end mill for this first example. Because this was copied from the Fusion 360 samples, let's make sure that we select aluminum finishing and select the tool. Remember that we reset some of the feeds and speeds to 8100 RPM, and we're moving at a cutting feed rate of about 125 inches a minute. For our geometry, there are multiple ways in which we can contain the geometry of a 3D contour toolpath. The first thing that we want to explore is the slope option. When we're looking at a 3D contour toolpath, oftentimes we're looking at near vertical walls, and we want to avoid certain areas. We can do this by restricting the slope between a certain angle. For this example, let's go ahead and restrict the slope between 10 degrees and 89 degrees. This is going to avoid vertical walls and horizontal walls, and it's going to only focus its attention between 10 and 89 degrees. We also want to take a look at some of the options inside of our contours passes. You can see here that by default there is no stock left over, and we have a maximum step down value of 0.125. There's also a cusp height value. The cusp height is going to control the maximum step down, and this is a value that's going to be important to us as it's going to determine the cusp that gets created on our part. We're going to leave these values as stock for now, but we are going to come back and make adjustments. Once we say OK, notice that it is taking a look at the entire part, but it's only focusing its attention on this face as well as these faces that fit within that 10 to 89 degree angle. It's avoiding completely horizontal surfaces, and it's avoiding this face, which is below 10 degrees. So this is a good way for us to identify different areas by their slopes. But let's go ahead and go back and edit this toolpath. In this case, in the passes section, we want to change the cusp height to be much smaller. I'm going to use 0.003, and notice how it adjusts our maximum step down. Where we used to have 1/8 of an inch, now we have 0.038. We'll say OK and allow it to regenerate. I'm going to go to my toolpath visibility and turn those off, so we're just taking a look at the stock. You can see that it's getting relatively close to a good finish, but we are still seeing a preview of those cusps. If we view this from the front, we can see exactly what's happening. Under the tool visibility, let's go ahead and show tool. We're going to show the holder and shaft and the tool on cursor. This is going to allow us to get a good look at what happens as the tool moves down the part. Because it's moving back and forth in this 3D contour, what's actually happening is it's creating this little raised and valleyed section each time the tool moves down. One problem that we get with using a tool like this on a slanted face is that you have to have a really small step down value in order to get a smooth finish. It's just something that we can't avoid. However, there are things that we can do to make this a bit easier. You can always use a larger tool, and that will reduce the amount of steps that you need to take. For example, in this 3D contour, we can select Edit, and instead of using the 1/4-inch ball, let's go into our 3-axis library and select our 1/2-inch ball and mill. We'll select this tool. I'm going to leave all the parameters the same, how they come in, and allow it to regenerate. You'll notice that we still see a cusp on this part, and part of the reason is the parameters get changed when we select a new tool. So let's go ahead and evaluate the cusp height and the maximum step down values. You can see here that we've got 0.03 set as our cusp height, which gives us a maximum step down of 0.06. Let's go ahead and select OK and review this one more time. We can see here that the cusps look a little bit different. They're further spaced out, but we do still have a cusp to deal with. Once again, this is problematic because we do need to have a relatively small step in order to get rid of that cusp with this tool. But for now, let's make sure that we just understand how we can restrict the tool by using slope, and then we can move on to the next toolpath. So let's select Activate, and then let's make sure that we save the design before moving on to the next step.